All right, I kind of ran out of time, but I think that we did okay on that. It's pretty simple. If I increase the pressure above a liquid, the gas will stay in it more. If I heat a liquid, the gas comes out. If I agitate the liquid, the gas comes out. All right, now, the last little tidbit that we're going to have you do right now is called colligative properties of a solution. All right, that's a fancy way of saying that how solutions deal differently than their pure solvents. So how is salt water different than water? Now, a common question you asked, in fact, I think Kyle in second hour or third, right now they're all running together, but I think Kyle, you asked me if salt water can freeze. You've learned over time, and most of you have, that salt water freezes at a lower temperature. It will freeze, it just freezes lower. The reason why is this property called a colligative property. Salt water, all right, so NaCl, that's salt. Salt water has different melting and boiling points than just pure water. I should write H2O in here. All right, the fancy term is called colligative properties. All right, so the colligative properties of a solution are different than those of the pure solvent. All right, colligative properties are physical properties that depend on the amount of solute in a given mass of solvent. All right, now, this has a fancy name. This is the only time you'll hear it unless you take AP Chemistry. It's called the molality. Now, you do not need to write that. Molality. It's the amount of solute in milliliters over kilograms. So it's kind of a weird one, but it is useful in AP Chemistry. It helps us learn these colligative properties. All right, so what are they? Our boiling point is elevated. It is higher than the boiling point of the pure solvent. All right, now the freezing point is depressed. It is lower than the freezing point of the pure solvent. All right, now the magnitude of the change is directly proportional to the molality of the solutes. Don't really stress about that. And especially there's the math right there. You do not need to worry about the math. Just conceptually, I want you to think about this. All right, if you remember our heating curve for water, and if you don't remember it, it's on page 2 or something like that. We had this line, then it went flat, then it went up, then it went flat, and it went up. Sorry about that area right there. All right, now here we said this was our solid, this was our liquid, this was our gas. All right, so what this is saying up here, it says boiling point is elevated. So that's this region right here is higher. And this region, the freezing point, is lower. All right, so in blue pen, I want to rewrite how this would look if it was salt water. All right, so we would have our line, and whoops, that's not a good angle. We would have our line, it would be lower, and then our line would roughly have the same angle, and then it would go flat, higher, and then it would curve again. All right, so the colligative properties cause it to be liquid longer, right? Over a greater range of temperature, this substance will maintain the properties of liquids. All right, this is all you really need to know about colligative properties. Don't worry about the math. Remember these two things and this little graph, that the liquid state remains longer. All right, that wraps up this little bit. We'll probably have more. Thanks for your patience. I know I sound boring. Bye.